All right, so in part B, we want to find tangent lines at some different values of x. All right, so if we have, so if x is equal to 0.01, then y equals log base 10 0.0, 0.001, and that's going to be -2. You can throw it into a calculator, or this 0.01 is 1 over 100, which is 10 to the -2, 10 to the -2, right? So that exponent is going to give you 2. So if x is equal to zero point 0.1, y equals the log of zero point 0.1, that's going to give us -1. If x is equal to 1, y equals the log of 1 is going to give us 0. And if we have a 10, we're going to get y equals the log of 10, which is just equal to 1. All right, so those are our x and y values. So then we can find slopes, right? We found from part A that the slope is 1 over the natural log of 10 times x. So f prime of 0.01 is going to be 1 over the natural log of 10 times 0.01. If I wanted to, right, so probably a nicer way to write this. So this is 1 over 100. Since I have 1 divided by 1 over 100, this is going to be 100 over the natural log of 10, if we wanted just a different way to write that. Right, that's going to make it a little bit easier to see what we have down here as well. Right, this would be like 1 over the natural log of 10 times zero point 0.1. So that's going to be 10 over the natural log of 10. No cancellations or anything there. So f prime of 1 is going to equal 1 over the natural log of 10 times 1. So just 1 over natural log of 10. And then here, f prime of 10 is equal to 1 over natural log of 10 times 10. And we can write that a lot of different ways using like rows of exponents for logs. So in terms of tangent lines, we would get this first tangent line. I'm going to call it maybe y1 is going to equal, let's use Taylor form, f of a. So where y value is -2 plus the slope 100 over the natural log of 10, and then x minus a, right? So x minus the value of a that we used. This first one was 0.01. That's going to be our tangent line. Y2 is going to be -1. That was our value of y that we found, plus the slope, which is 10 over natural log of 10. X minus zero point 0.1, our third line. So we got 0, right? In this case, our y value was 0. Our slope was 1 over the natural log of 10, x minus 1. And then finally, our fourth line is equal to 1 plus 1/10 natural log of 10 times x minus 10. So I'm going to pause the video for a second just so I can graph all of these things into the function. Then I'll re. All right, so I added all these lines to Desmos. So here's our lines in Desmos. So I added a table so we can see exactly which points are being hit by each of these lines. So visually, we can see, right, if I kind of go from the smallest, right, so this line has a super steep slope. If I compare that slope to this blue one, right, the red line obviously is a bigger slope than this blue one. And we can see because 100 over natural log of 10 is bigger, much bigger, than 10 over the natural log of 10. If I add in this one, right, so that green line has a much smaller slope. And then if I look at this orange one, so it has a much steeper, sorry, much narrower slope still. So we can see that as the value of x is increasing, our slopes are gradually decreasing and becoming closer and closer and closer to 0, right? So that's kind of like the key thing to pull from